right. My name is Rebecca, and I am a youth services library worker here at Central Library. And I am excited to share some math and science tips and information with you guys today.
And I'm Holly Broman. I'm the children's librarian at the Central Library. And so I wanted to start by telling you all how this Zoom webinar works in case it's your first Zoom webinar. It's a little different than the regular Zoom. There is a Q&A feature, which is a way for you to kind of anonymously submit questions to us and also allows us to keep track of those questions a little better. So if you want to put questions in at any time, we will be checking there frequently and we'll try to get to those. And then there's also the regular chat feature, which you can choose to send chats to just the panelists or to an individual or to the whole group. And of course, we are not sharing any video of any of you, just the two of us panelists. So I wanted to also ask how many of you are repeat viewers. This is only our second one, but we're really excited to see if anyone has come back after watching the first one. If you have, just say yes or me or something like that in the chat and we'll be happy to see it. But to new people, welcome. So we're talking about math and science this time. Let's get into it. The teaching kids early concepts of math and science can help them build the foundation for these subjects throughout their school years. And school is putting an emphasis on these things, especially with the future that we're seeing where we're going to need a lot of scientists and critical thinkers. And so we want to start building that kind of process early. And you don't have to be a mathematician or a scientist and have all this kind of expertise to teach kids math and science. The main things, especially for these young ones, is to start teaching the basic skills of asking questions, exploring the world, talking about math concepts like the shapes, the numbers, comparisons, like what color is this and what color is that, and making guesses, which is kind of like how we are always making hypotheses in science. So we're going to emphasize that with our interactions when we are thinking about science and math early on. As long as you show that you're interested, then they're going to be interested and invested in the interaction with you and learn and have fun. You can do it during play like these children and their caregiver. And you can just even do it during snack time, right? How many crackers do you have right now? Oh my goodness, you ate 2. How many do you have now? What do you think will happen next when you eat another one? There's some prediction, there's some math. So why is math important? We wanted to get some of your opinions on what you see as the importance. So if you take a moment to put something in the chat about why you're interested in math and learning about it and teaching it to your kids that you take care of. I'll give you a little time to put something in the chat. So mathematical thinking is important because it helps us learn how to reason and think logically, connect our ideas. And it's the basis for a lot of really decision making in life, really, if you think about it. And even before school, it's more than just the numbers that you're learning, although that is part of it. The math that you can practice before starting kindergarten includes things like sorting. So you could see that this little girl is sorting things based on their color. She has green sticks and blue sticks and red sticks, and she's putting those in categories by color. She's also learning some numbers there. You can see recognizing numbers in print by pointing out things in their toys, in the signage around you, the clock on the wall, the calendar, and you can get them involved in helping you with those tasks of what time is it, and that sort of thing. And they're going to be engaged in learning and helping. They love to be helpers. So you can also notice that there's patterns both in nature and in things that you create together. So this little girl might also use these sticks to go green, blue, green, blue, green, blue. Is that a pattern? Could she make a more complicated pattern? What sort of things is she noticing when she is playing with those? And what's predictable? And if you're making the pattern, that's a great game because you can do green, blue, and then have her guess what comes next. So there's also, of course, counting. I love finger plays for practicing counting because it helps develop the muscle memory to go along with practicing counting. Sometimes people think like if you have to rely on your fingers, that's a like handicap, but it's really actually really helpful when kids have learned how to count on their fingers. They tend to be able to grasp concepts in math much more quickly. So we can talk more about finger plays later. Using words that talk about the position. This is another opportunity that you can take both in your daily life and by making a game out of it. So you could play with the favorite toy and put it under a blanket and then over the blanket and then drive it around the blanket and ask while you're doing it, where is it now? What is it doing? And talk with your child about it. You can also talk about your routine using the words about the order, first, next, last. So before you head out the door in the morning, first we're going to put on our shoes. Next, we're going to put on our jacket. Last, we're going to open the door and head out to the car. So those are ways that we can start using basic math concepts in our everyday life. The crackers, I talked a little bit about that already, but you can include numbers in things like snack time, right? Basic. Some fun math activities for your littlest ones, your infants, include singing songs and rhymes and a lot of repetition. Old MacDonald is so repetitive, it starts getting them to be able to predict what comes next. The E-I-E-I-O every time, right? And then things like zoom, 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 we're going to the moon has a 10 countdown at the end, so they can practice that 10, 9, 8, blast off at the end. There's lots of songs out there. Another one of my favorite counting ones is the 5 green and speckled frogs. That one is also counting down from 5. And you can also pick out books that have numbers, and all books have sequence because there's the beginning, middle, and end. So it's a good way to start talking about that order again. Number of stories that are out there that I really like are One Very Big Bear. It's really cute with lots of polar animals and a polar bear. 1 Leaf, 2 Leaf, Count With Me. Very cute. Just fall story time book. Color Zoo by Lewis Ellert. A lot of books by Lewis Ellert have great shapes and opportunities to count and learn about comparing size, shape, color. And that's another part that we want to emphasize when we're talking with infants about math concepts. And there's lots of exploring the world that infants do through their touch and just exploring. And so you want to offer them things that are different and similar to play with, both with their texture, with their size, with their color, and you can talk with them about those things too. For toddlers, when they're learning math, bubbles. Bubbles are such a popular hit with toddlers. I mean, most kids, even babies, love bubbles. So as you're popping those bubbles, you can count. It'll give them a great sense of accomplishment and a great way for them to practice their counting. And you can learn your patterns and your shapes by using your snacks. You can use little cookie cutters to make different shapes, or you can just use what things naturally come in shape-wise, right? Crackers might be square, some of them might be circular. The cracker is a favorite today. So every day, making those comparisons, maybe you have some puffs on your plate and some raisins. You could practice making little patterns with those. You can play follow the leader, counting your steps as you go. There's lots of things you can do with that. And you can go on a shape hunt around your home. There's lots of natural ways to point out things that have to do with math around your house or your neighborhood or at the park. There's shapes, there's numbers, there's patterns everywhere. So for the preschoolers, they're going to be able to do a lot of big muscle movements, right? And they're going to be really ready to do that and waiting. They will love to make shapes with their arms. You can have them go like this, to make a circle. You can do it and have them guess and then repeat after you. And they're gonna love it, and it's going to help them remember that better. When things go into your muscle memory as well as your cognitive memory, you're going to remember it better. So there's also learning patterns through music, clapping, right? You can do it with a pattern of rhythm, or you could go really loud clap, really soft clap. And then there's also things like singing your song faster than slower and things like that. Patterns can be found in music in a really fun way. You can also play guessing games, and those are really fun when you're doing things that have to do with time. So how long do you think that this will take, or how big do you think that the bread we put in the oven is going to get, or that sort of thing. How long can you stand on one leg as it says there, or how many steps will it take to get to the car, or how many steps until your brother gets to us, or something like that. There's lots of ways to guess in your everyday life, and that's a great way to practice making predictions. There's also lots of fun board games out there that are appropriate for preschoolers. Two of my favorite are Chutes and Ladders and Hi Ho Cheerio. Those are great for practicing counting in a simple way. And board games are also great for practicing social skills, which we talked a lot about last time in our session. You can still check on YouTube. You can also play matching games, those memory games that you turn over 2 cards at a time. That's a great game. But you can also do it just with items around the house. Find 2 things that are blue. Find 2 small things. There's all sorts of ways to play and learn through play. So this is an example of a sorting activity. So you can gather things from around your home. You can have them help you do that. And that can be a fun game of like everybody pick out 3 things from around the house. And then you can ask like things like, how many did we end up with? How many look the same? How many seem different? What are the things that make them the same and different? And then you can sort based on those things. And you might be able to try a few different ways of sorting. Maybe some of the things are really soft and squishy, and some of them are hard, but also maybe some of them are all blue and some of them are all red. So which one do you want to sort based on first? Could you sort on both? There's lots of ways to start thinking through the concept of how you compare things and how you categorize them. So then you can see how many groups you ended up making and how many are in each of the groups, and you can compare those group sizes too, right? Even more comparison. Are there more in the squishy group or more in the hard group? And then you can mix it all back up and see what else you can come up with. Lots of toys out there that can help teach math. The blocks and Legos and Magnetiles are great for kind of starting to learn engineering concepts, but also starting to learn shapes. There's lots of shapes and colors in all of those toys. And you can also use things to build with and compare that are just empty containers. And there's lots of those around the house when you use things up or you get a new package in the mail. Go ahead and get creative with them. Similar toys or different toys are another way that you can use just toys around the place to talk about math, and also the different textures. Cause and effect, that's a big one for learning prediction, and toys that have buttons that make things pop up, or like there's some where you just put a ball down a chute, right? That's also cause and effect. It's rolling down every single time. It's the same thing. When you put it up here, it goes all the way down. So when they can see that every time that you do this, this happens, they're going to learn to make predictions and that there's a cause and there's effect. There's also Play-Doh and other moldable things that you can build with and make different shapes with and break them up into bigger and small pieces and count. And they're so adaptable. I think that that's the big thing of the moldable items. You can mold them into any activity. Playing cards is also great for starting to learn math. I think a lot of people might remember times when an adult just said it's 50 card pickup. Just drop the cards and you count as you pick them up. That's like a little bit rude sometimes, but if you do it together, it might still be fun. And I think also things like Go Fish or Slapjack or lots of games out there that you can even make up with cards that can be really simple and fun and practice your math skills. So basics to remember, tips to remember, can use numbers in your daily routine and say those out loud. You can involve your child in that, either have them repeat after you or count with you. And you want to be reading together too. That really reinforces your skills and allows kids to be able to see the words and the numbers in print. And you also want to find books that have those rhymes that are really predictable and they can guess maybe what the rhyme is and start to understand those patterns. And you also want some repetition and numbers and shapes in those books. You can play games and sing songs, and use words in your play that are like first, next, and last, up, down, over, under, and patterns are everywhere and you can point them out together. And also those numbers and shapes, those are everywhere too. Building blocks, boxes, empty containers, other shaped toys. Basically, talk with your child, build with your child, point out things together. And then you can use your measurements tools when you're cooking and baking together and talk with them about that too. That's a great math activity and a science activity too, which we're going to get into science very soon. So this is a good moment to pause for some questions, see if any came in. And while you do that, I'm just going to share a favorite finger play. And Rebecca, if you have any favorites, feel free to think on that. I really like the bees in a beehive one. It's really fun for multiple ages. It goes, here is the beehive, but where are all the bees? They're hidden inside where nobody sees. Watch as the bees come out of the hive. 1, 2, 3, 4, 5. And then you can buzz and tickle. So I think that's a great way to practice that counting in a way that kind of makes it into a story. And if you're a baby, you get those tickles. If you're older than that, maybe you get to tickle somebody else. It's a fun one. I love it.
I just learned that one today at Baby and Me in the Park. It was a big hit with the little guys. So that's a lot of fun. Okay, so why is science important? Again, if any of you have some ideas about that, feel free to engage with that chat and let us know why you think science is important. Obviously, we have our answers, but we would love to hear back from you, and we want to know kind of what brought you here and what makes you curious about learning more about science for the little guys. So go ahead and think about that. One thing that we have, so what we're going to talk about today is that scientific thinking really helps kids learn about the world around them. They're going to investigate, they're going to discover, and every time they're interacting with the world, they're actually learning about science. So just absorbing everything as kids do is really going to be a great foundation for science throughout their school career. We're just going to give you guys a little guidance here on some tips to mold around that so they really get into the mindset of thinking through scientific terms. So there's really 4 main types of science that they're going to be studying when they get into school. And so that's chemistry, which is discovering what things are made of and how they can change. Earth science, which is just exploring the environment and how the earth works. Biology, which is living things like plants and people and animals and everything little and big and in between. And then physics, which is energy and motion and sound. And those are all kind of intimidating subjects, right? Because we're working with little kids. So we're working with preschoolers and below. Then it's sometimes difficult to think about, like, how am I going to teach my infant physics? Well, the great thing is that they're actually learning all of this stuff just by interacting with the world. So when you look at this picture over here, we have a little boy playing in some sand, probably at the beach. He's actually engaging in all 4 of these scientific categories already. So he's picking up the sand and he's throwing it in the air. Guess what's happening? He's mixing air and sand. Those are 2 chemical elements that are found naturally in the world. That's already chemistry. If you add in water, that's a whole nother mixture. And he's going to be able to learn about what changes with sand when air is added, what changes with sand when water is added. You've got a foundation for chemistry. It's part of the earth, right? Sand, the beach, the ocean. He's already learning about what sand does as it interacts with the beach, as it interacts with our footsteps, how maybe it different on a windy day, or what happens to sand on a sunny day, right? We all have probably experienced some very warm, sunny sand. Biology, sand is so full of living things and things that have come from the ocean and things that are they've got little creatures that are growing in all of the seaweed that's pushed up. It's full of life, it's full of biology. And then here he is, he's experimenting with physics. He's throwing the sand in the air. What's happening to it? It's moving, it's changing in the air. It's probably making sounds or not when it falls. So even though science can be a really intimidating concept and we have these kind of big words to explain things, at this level, they're already exploring all of these foundations. So that's kind of what we wanted to get you guys started with, just knowing that you don't have to be intimidated by science. We're all scientists at this level, and we can teach them just through exploring the natural world around us and exploring themselves and exploring other people and places, and all of that is all science. So something that we want to talk about is how to mold them into scientific thinking. So this is a way that you can contribute as a caregiver or as a parent to really encourage them to think in these scientific terms. This is going to be a huge help for them when they get into school. So the scientific method is actually this very basic formula that all scientists use, that they're going to use throughout their career as science students and beyond. So it's 5 steps. You're going to ask a question. How do we think this is going to work? What makes this work? What do you think is going to happen? And then we're going to make a guess. There's a fancy word for that called the hypothesis. But guess what? It's just making a prediction. And their predictions when they're little, they might be all over the place. That's totally okay. We want them to be making guesses however they want to make them. So they can be the silliest guesses, the most out of this world guesses. It doesn't matter, because then you're going to test it. So you're going to do a little experiment. Let's try and see if that works. And then while you're doing the experiment, you help them observe what's happening. What do you notice? What things are changing, what are not changing, what is making what happen. And then you draw conclusions, which is just talking about it when you're done. So what did you see? Do you think that worked? What do you know about your hypothesis? And then with the scientific method, what you always do is, if you don't have a conclusion that matches your hypothesis, you go back around and you start over. So you ask a question and you move from there. So it's a big circle, and it's really how it doesn't have to be complicated at all. You can use it with everyday things. So we're going to have an example here with ice. So pretty much ice is a pretty easy thing to come by for us. So this is a good experiment to practice when you just want to do something a little more structured, but you want something that's easily on hand. So you're first going to ask a question. Does warm water affect ice? And then they're going to make a guess. And here's our hypothesis here. Will the ice cubes in the warm water melt differently than the ice cubes in the cold water? They might say no, they might say yes, they might say they don't know, but we don't take I don't knows as answers. We're going to get a guess from them, right? So then you're going to do the experiment. I suggest putting a timer up so that you have a little bit of a structure and you're not watching the ice all day. Something like 5 minutes is probably enough time to notice differences. Put some ice cubes in warm water, put some ice cubes in cold water, and then observe them. What's happening with the ice cubes? When you're just starting out with this, have them talk through it with them. We see this one moving faster, this one moving slower. And then the conclusion. So the conclusion, as adults, we're gonna know probably the ice cubes are gonna melt faster in warm water. So we're gonna let them decide what happened, right? Did they answer their hypothesis? Was their prediction correct? And then maybe they weren't. Maybe they thought it was going to melt faster in the cold water. You can go back and try it again and do different combinations. Maybe leave one in no water. So tweak the experiment, do it again, practice different hypotheses. And that's a really good way, a really simple way to practice this scientific method. which again is just a great foundation for every study of science and every area, and they're going to use it throughout their school career. Okay, so since we're really talking about boosting school readiness, what we want to think about is what things they can practice before they go to kindergarten. And after that, let the science teachers kind of take over and just support. But some things that you can practice is asking questions. So we already talked about that. Asking them what they think is going to happen, why that happens, or how. There's so many questions that they're asking. Ask them questions too, right? If they're going to be asking you what this is, that's great. That's scientific thinking. Turn it around on them. Ask them questions too. Make them think through this process and have them make predictions. Again, doesn't matter how crazy they are, how wild they are. It doesn't matter if you know the answer. Let them work through it and figure out if their predictions are correct. And especially when they're little, we got our infants, but moving all the way up to preschool, they're going to be using all of their senses to discover how the world works. So looking, listening, touching, tasting, and smelling. And that's actually a way we get information as people. So we're processing the world and we're categorizing it as data collection for us. And as kids grow, they're going to be able to explain what those things are more. And then they're going to be able to use that information to answer questions. So it's all collecting the information and bringing it back. So letting them try new foods, letting them hear new sounds, go out smelling different things. Doesn't have to smell good, right? So trying out different uses of senses. And then just looking at surroundings and testing ideas. Maybe they think if I swing on my stomach, I'm going to go faster or something like that. So trying out different things with them on the playground, in the park, or in the house, let them try their ideas. And then using really simple tools. This can be, it doesn't have to be really complex science kits. It can be things like flashlights and measuring cups and tweezers and building blocks and all of those things that are going to help them with engineering and with science and just discovering those 4 things. So what happens when they mix together? Is it alive? What does it look like when it's alive? How does it affect our earth? And what happens when we move or with motion and work with motion and energy? Okay, so we're going to talk about infants first. Some things you can do with infants. Some people, it's like, what? How do I do science with infants? They're already, remember, absorbing everything in the world. So they're not going to know the whole scientific method, but you can start introducing that really early on. So just being out in nature. So going to the park, going to the beach, laying out a blanket, listening to sounds, talking about the breeze you feel, or the sounds of kids playing, all of those things, just talking through it. Infants are already sucking up all of those words and learning all of that information. So reading some nonfiction books together. These can be books about animals or people or the senses or the world in general or how things move or how sounds are made. And then a lot of times nonfiction books are kind of forgotten about, right, in the reading process. So obviously we love reading at the library. We want to encourage nonfiction reading too, because it's a good way to introduce facts about the world that maybe they wouldn't be getting otherwise. And then experimenting with their senses, experiencing, again, those smells, sounds, different tastes, different textures, feeling things, touching things, tasting everything as infants, right? Introducing them to new people and or pets. So maybe you have some neighbors with some friendly pets. So you can let them meet them, let them talk about or feel different textures and hear different people talking. Those are just using those senses and exploring the world around them. Tell them the whole time about who they're meeting and what they're doing. And then trying out different forms of motion, right? This kid in the swing, he's learning about physics already. So that's a really awesome way to just get them interested in motion and moving. Kids love bouncing. They love rocking. They love being able to do all of these things with you as helping them along. So it can be a little scary to get infants involved in motion, but it's a really great way to create a safe environment to explore how things move. All right, so getting into toddlers. So sand and water are going to be so great for toddlers because these are things that move together differently. They form in good ways. Dry sand is different from wet sand. Water is different without sand in it. So you can go to the beach. That's always a great option if that seems like a big trip to go. A sensory table or a bucket or a sink, anything like that, to fill it up with sand or water and play with different toys in it, see what happens when things we got here in the sink. If you fill it with water, do toys float? Do they sink? What's going on there? And exploring the world again, touching leaves, finding flowers, smelling them, maybe not tasting them with leaves and flowers, but getting those growing things involved. And then paint. Paint is a really great way to practice chemistry and practice mixing of things. It's also going to help us with those math skills we already talked about because we want to learn our colors. So mixing paints together, using them to create new colors, seeing what happens when you mix them all together. And if you still like that color, let them paint with that. It's great to get messy as a toddler. And then building towers and walls with blocks or other building materials, persevering when they get knocked down, and making that part of the fun game too. Because building towers is part of our engineering skills. It's how we're using those math skills in a really practical way. Knocking them down, that goes back into our motion, right? So we're talking about our physics. So it's totally okay to knock those towers down. That's still science. So talking about it again, what happened? How did that happen? What do you think we can do to keep it from happening next time? So practicing with those different building materials. Okay, preschoolers are at the age where they're really starting to be able to do so much stuff with science, and they're going to be asking so many questions about the world, and they love experiments. They love playing with lots of different things and getting really messy, and all of that is going to be so key to them going on further into school. So a fun thing to do is let them play dress up, play a game where you're saying, what are you going to go find me an outfit that you would wear if it's raining? Or what are you going to wear if it's snowing? It's really fun, even in a place like Santa Barbara where we don't have a lot of different weather, because how else are they going to learn if not by pretend, if we don't always know what snow looks like in a place like this. So playing pretend, bringing that in, is a really great way to introduce them to the different weather patterns. Taking magnifying glasses and going on a bug hunt, or looking at leaves really closely. And kids love magnifying glasses in general. So looking at things close and what does it look like and how is it different? Planting some seeds. You can even pull them out of just like a lemon or an orange that you're cooking with, and plant those and see if they can grow. Water them every day and let them kind of take that on as a project. Using light. So light's a really fun thing to do that's really easily accessible throughout the house. So it can be a flashlight, you can do lamps, you can put stuff over windows and make it dark. You can do shadow puppets, or you could cut out stars and paper and hang that on a window. All of that's practicing how light works, which is really great practice for science. And then magnets. Magnets are a really fun thing. Go on a magnet search. What does it stick to? What doesn't it? And then also getting into recycling. So that's getting into our earth science, right? What does recycling mean? Have them help you sort it out, right? If it's a chore, it'll be less of a chore for them and less of a struggle to get them to help if you make it a science thing, right? Make it an experiment. What happens when we do this recycling, and how do we sort it the best? So that's a really great way that they can practice science and help out around practice their cleaning up skills and everything as well. So some toys that you can use. There's tons and tons and tons of science toys out there, but like I've said this whole time, it's really just about exploring the world. So they don't really need a lot of fancy toys or kits or any of that. Those are great. They can be really fun to play with, but using simple toys too, and simple tools, and just getting out into the world and testing out wind and rain and all of that, and just looking at the world, that's going to be key to building this foundation. So you can use measuring cups, magnifying glasses, binoculars, like I said, flashlights, things to pick stuff up like tongs when they're littler, and then getting into tweezers to work on those fine motor skills. And then you can do things with sounds and multiple features. So those are sometimes those cause and effect toys, like we were talking about with math. So something, you press a button and it makes this sound. When I do this, it's going to do this. It's going to be scientific thinking still, right? It's getting them to predict what's going to happen and think about ask those questions, predict and conclude, which is ultimately what we want to get them through in the scientific method. Using bubbles and trying out different bubble sizes with different bubble wands. That's a lot of fun. Taking out kites or bubbles again on windy days. It's always fun to use the wind to help them explore the world instead of trying to avoid the wind, right? So how do we get out in the wind and use that to learn about the earth? Building toys, marble runs, race car tracks. Again, we've got those Legos and those magnet tiles, all of that. That's where math and science really come together to form those engineering lines. And then puzzles are really great for that logical thinking. Sands and slimes, anything that's kind of gooey and messy that they can really get their hands into. Kind of grosses adults out sometimes, but it's so great for sensory learning for kids. And they're going to have so much fun just really digging in and being allowed to make a mess and learn that way. And then musical instruments is so important for sound and energy and teaching science in a different way. A lot of times maybe a kid doesn't like being messy so much, but they might be more musically inclined. So that's a good way to get into rhythm and volume, and all of those are going to connect back to that motion and energy process. Okay, so some tips for all ages that we can look at here is we're going to encourage children to explore and make discoveries in the world. So we want them getting out there. We want them being a little risky, right? A little risky within safety is really important for learning. So obviously use your best judgment as caregivers and parents on those risks, but thinking about even like a jungle gym, that's going to be something that's a little risky, but it's them practicing on climbing and heights and learning how slides work. All of that is really helping them discover how all of these scientific practices. And then ask them lots of questions. Like, what do you think will happen if? Let them answer. Like I said, they have a million questions for us. Turn it around on them sometimes. Have them think through the process. Of course, answering their questions when they ask it as well. But what do you think is going to happen if I put this, when I mix this egg with this flour, or something like that? Having them explain how they think things work. Have them come up with whatever they want. It could be all over the place. It could be they think lights are lit up by fireflies, something like that. That's totally okay. We want them to think through this, use their imaginations, use those prediction skills as creatively as they can. So cooking and baking together, I already mentioned that with like eggs and flour, but it's such a great early chemistry practice that everybody is going to be kind of practicing at some point in their life. So cooking and baking are chemistry, right? How things come together and change. It's a really, really good way to incorporate our math and science as well. Spending lots of time in nature, checking out different types of weather, and then of course, reading books about science and nature. So those are kind of how we get all the things that we can't find in our own community. So bringing in books about things that, again, things like snow, we can't really find in Santa Barbara unless we drive. So bringing in books about that and dressing up for it is a really good way to get them excited about different types of weather in the world. Okay, so those are kind of our foundations of math and science. And in our last little bit of time here, I'm gonna go through some school standards. So these are the standards for school, K-12 school. So these are things that they're going to be learning throughout their entire K-12 experience. So don't be too intimidated by by what these standards are. They don't need to know all of these going into kindergarten by any means. But we want to kind of connect you guys to it, because a lot of it is covered in just these early experiences. So a lot of this is really already setting them up to be successful throughout that school career. So in California, they use the Common Core math. Common Core is kind of a really scary, big new thing to a lot of parents and a lot of early educators who don't necessarily, it's not necessarily the way that, it's not the way I learned math. It's not the way a lot of us learned math. So it can be intimidating. But I just want to look through, these are the main aspects of Common Core math. So thinking about these, I'm going to talk about kind of how they connect with what we've already talked about today. So making sense of problems and persevering to solve them. So that's going to connect with our scientific thinking and our mathematical thinking, right? Like, maybe I didn't get the answer this time. How do I go back and solve it correctly? That's all it is. It's really having the patience to keep trying when things don't go right. Reasoning abstractly and quantitatively. This is going to go back to those guessing games we're making, right? Like, so how far is it to get to the car? This is something that's abstract, but we're reasoning with numbers. So using quantities with abstract thinking is going to set them up for that. So asking these questions and having them think it through, that's really the foundation for that. Constructing arguments and critiquing the reasoning of others. This just means that they are able to say what they think something is. So I think the answer to that is going to be this pattern, red, blue, red, blue, red, blue, because I've seen that pattern before and that's what it looks like. So modeling with mathematics, this is just using what they know about math to solve everyday problems. So again, when you're asking them to do things like take 2 crackers at snack time, they're going to count 2 crackers because they've learned what 2 is. So it's connecting those numbers that you're already working with to solve their own problems for themselves. And then using appropriate tools, this gets into things like using pens and pencils and crayons and blocks, and even they're going to later use calculators and protractors and all of that. So it's math tools. When do you use them? How do you use them? As preschoolers and below, it's going to be a lot of crayons and shapes and sorting activities, and when to use them and how to use them. Attending to precision really is just explaining things as they're doing it and using that to get the right answer. So making sure they know the details of what they're talking about. So the best way to practice this is just get them talking about what they're doing. I have, in the sorting activity, we have 5 groups. And how do I know there's 5 groups? Let's count them. 1, 2, 3, 4, 5. That's all right. That's all we want from them when we're talking about precision at this age. Looking for and making structure and looking for repeated reasoning go together. It's really just seeing patterns. So it's I see this pattern and I saw this pattern again, and there's a pattern I see every day in my house on the carpet. It's red, blue. And so I know that every day I'm going to go into that room, I'm going to see carpet that's red, blue, right? So it's really just categorizing that information, those patterns that they're looking for in the world, and bringing it all together. Okay, so let's look at, this is what Common Core math is going to look like. But again, this is not something that we need any preschoolers to be doing, but it is really just one of the things that we learn in Common Core is using models. So using those tools correctly and that information. So drawing pictures to back up your arguments, or seeing patterns and knowing the inverse. So like number bonds are really important because 7 plus 3 equals 10. But look, 3 plus 7 also equals 10. So that's how we're using those patterns to create stockpiles of information in our brains. So don't worry about knowing any of this. We just wanted to give you guys some examples of what it will look like when they're headed off to school. But really just having the foundations and talking about all of these problems is what's going to get them there. Science. So science, you're going to be following this, the teachers are going to be following these different structures. So asking questions and defining problems, part of the scientific method, right? Developing and using models is really just figuring out how to use diagrams and models and different graphs and all of that stuff. That's what they're going to end up doing. Preschoolers aren't going to need to do that. But what could you say? You could say, let's go build a really tall tower. And then they're going to go build a really tall tower. And then they can explain, here's my really tall tower, right? So using that information to back up their language is really what we're looking for here. Carrying out investigations, again, that's part of our scientific method. We're making predictions and we're testing them out. And then analyzing and interpreting data, that's just our conclusion. What happened? What did we collect? What information did we learn? Using mathematical and computational thinking. So that's where we're getting into how the math and the science go together, right? So there's a lot of overlap with these two, which is why we talk about them together. And then developing explanations and designing solutions. It's just really a fancy way of saying, again, we're creating explanations and then we're trying that again. So we went through the scientific method and I predicted that the ice was going to melt faster in the cold water, and it didn't. So what do I do to go back and do that again? And then engaging in argument. So this is really going to be very important when they get into higher science, where they have to back up what they're saying. But really right now, it's just about asking those questions and making predictions and then testing the predictions. So it's really just the scientific method repeated, doing these experiments over and over. And then finally, obtaining, evaluating, and communicating information. So this is where we really want them to practice talking to you about it, right? Because it's really important for them to be able to communicate clearly what they found. So using that language development to explain what they see and explain those observations is really what this final one is. And then these are some cross-cutting concepts. So that just means they go across math, they go across all of those types of science we talked about. Patterns are science and math, and they're in physics and chemistry and biology and earth science, right? So that's what these mean. They're in all of those disciplines. And then we've got cause and effect, scale and proportion and quantity, systems and system models, energy and matter, structure and function, and stability and change. All of these are things that are just going to be discovered by them as they interact in the world at this age. So before school, they don't really need to know what any of this necessarily means. They just need to be practicing with those tools in order to learn it. And again, we're gonna end off here. This is they're just at the starting point now. So they have so much to learn about math and science, and they have so much that they're going to do as they grow into their school careers. So just practicing all of these things is really going to set them up for school success. So I'm gonna go ahead and exit out of this here so that we can let me stop sharing. And then we'll take any questions that you guys have about any of these topics.
Mm-hmm. So we will be here waiting for any questions to come in. While we're waiting, I'm going to go ahead and put a link to a very brief survey in the chat. It is just to help us evaluate how we're doing and what you're all coming here for.
Mm-hmm. Yeah. And also, just if you guys want to put in the chat again, kind of thinking about how you think you'll use this training in your lives with either your kids or kids you're taking care of, if you're caregivers, what you found from this and how you're going to use it moving forward. You guys want to share that would be great. Any final questions? We have about 2 more minutes before the end of the hour. If you have anything last to add.
I have a question while we're waiting to see if any questions come in. A lot of the science stuff that kids need to know in school, they don't necessarily need to know before school, but what are some great science vocabulary words that we could start teaching preschoolers?
I think for sure we've got the big questions, right? So, how, what, why, when, and where. So, those are the big questions that they should be asking, and we should be asking them. Um, and then I think just really talking about size. So, or size and difference in alike. So that's big, that's small, or that's soft, that's hard. Anything that's those kind of opposite words where we're talking about comparisons, those can be really great for getting them set up for science. I don't know if you have any more that you have on in mind, Holly, too.
I was kind of thinking about density. Like you can say, like you don't say that often, dense, or I guess less dense is there's not a great opposite that I can think of. But that's the main thing when you're looking at buoyancy, like what floats and what doesn't, is density. And there's lots of things like that out there. And I feel like that's a vocab word that you could just throw out there pretty easily. Is like, oh, this bread is dense or not, like
Definitely. I think the more descriptors they have, the more set up they're going to be for science. So, just describing things with their colors and their, like Holly said, density, texture, anything like that is going to really set them up to have the correct language for moving into science.
thank you for joining us today. And we'll be back next month with literacy. So we'll see you then.
Oh, thanks all everyone for coming, and we hope to see you again